So my glorious plan is basically based on the vibe of, um, it sure seems like just a really powerful model diffing technique is just take the Kale divergence of the two models on some things, and that this should just work. And I probably had like 2 to 3x as many streams done as put on YouTube, but mostly because of laziness rather than adverse selection.
You're just making yourself look so good on YouTube. I thought it'd be like 10 to 1 maybe.
Oh god, no. The ones on YouTube were generally the first ones I did, and all the more recent ones are like not on YouTube because I was just like, ugh, whatever. I have like 7 on there. It's fine. But I have no vibe coding ones. And this is clearly the most important thing to represent. All right, so where were we? SSH. Just copy the details. All right, so my plan is basically predicated on the general observation that if you want to understand how two models differ, you can just run both of the models and look at the Kale divergence on each token and look for points where they differ a lot, or look at points where one model can predict the next token correctly and the other model can't. And a thing that I'm quite curious about is whether it is the case that two models in the same family of different sizes, in this case, Gemma 2, 2b, and 9b, have the same behavior. They have like tokens where they are meaningfully different. Because intuitively, there should be some places. Sorry. Gemma 2 9b clearly performs better than Gemma 2 2b. We might hope there is some interpretable structure that goes into this happening. And the question is, A, does that structure exist? And B, how much is it kind of sparse versus diffuse? Like, you could imagine that 9b basically does everything 2b does, but just like a bit more refined with a bit less interference. And so it's just a bit more precise, and that's where most of the gains come from. Or you could imagine that mostly they are like basically the same, but there's a few tokens where 9b is way better. And hopefully this would be because 9b has learned some circuits or facts that 2b does not know. At least in the context of factual recall, you would kind of expect this to be true. Like, yeah, it just seems unlikely to be the case that the model will... Clearly, big models know things that small models don't. There is the confusion that plausibly small models like know a fact a teensy bit, but it's super noisy and not stored very clearly, and big models know those facts cleanly and then know some other facts really noisily, but maybe the loss comes from the kind of increase in precision more so than the like introduction of new really noisy facts. Kind of unclear. I mostly consider this an open question, but seems interesting. And yeah, so I basically want to just try to investigate what this looks like. If it looks like there's kind of interpretable sparse structure distinguishing the two, that's really interesting. If there isn't, that's also kind of interesting, but less interesting. And yeah. All right, so what exactly do I want to do? So I'll make a new Git repo for this. So it's like, what do I call this? I don't know, model family diffing public. May as well add a nice license in case anyone ever wants to use this. And yep, let's just clone this. And yeah. All right, so now I want to create a scratch file with the glorious, incredibly cursed line that just imports everything in my imports utils file. That is all of the utils I might ever want. And then does, I don't know, small model. Let's just not do. Let's do no processing for just simplicity. This means that it doesn't do the yeah. This means that it doesn't do things like folding in layer norm and centering things, some of which is actually kind of broken on Gemma 2 because they do weird things with the logits that is cursed, and I really hope doesn't come up in this session. And yeah, let's also make the big one, and let's just run this. But as much as possible, I'll be using cursor because A, RSI is a bitch, and also B, vibe coding is fun. And I want to see whether I am a gloriously productive researcher with vibe coding, or if I actually just waste more time dealing with random stupid bullshit than if I just coded everything myself. Anyway, while I'm waiting, let's ask, does anyone know Jake? You're muted.
Sorry. If you could just zoom in slightly in your IDE, I think that would be useful. It's just kind of hard to read.
Sounds good. Yeah, for stuff like that, no need to raise your hand to say it. All right, and honestly, I don't actually know if this is normal versus agent, but whatever. Okay. I am doing a research project where I have loaded Gemma 2 2B and Gemma 2 9B as small and big models, and I would like to download the Pile 10K dataset via Hugging Face datasets and just run both models on the first 500 tokens of each document in this dataset, take the per token KL divergence between them, and store this in an enormous data frame that contains the token, batch index, position index, KL divergence, log prob of the next token from the small model, log prob of the next token from the big model, and the 5 tokens before and after as text to give additional context. Let us see if Cursor is capable of doing it. I believe. Come on. You can do this. Its function names look legit. Good start. Good start. let's just assume it's entirely correct. And yeah, I guess I could read the code, or I could just like run it and see what happens. So let's run it and see what happens. And then I'll read it in part. What? It is doing weird things. Where it tries to download the entire pile, which is like 600 gigs, when it should have just memorized the glorious incantation Neel pile 10k, which magically solves everything. Basically being a random utility thing I put on Hugging Face a while ago, but just the first 10k bits of the pile. What? Why did that break? It broke because it thinks pile sample is a variable, and it is not. That is a reasonable reason to break. What does it think pile sample is? Wait, no. Why am I reading the code? I got rid of pile sample and instead downloaded a smaller dataset. Please refactor the rest of the code to use pile dataset instead, or convert pile dataset into the appropriate format such that it can be used by the rest of the code. Up to you. I'll kind of grant Cursor being confused by this one. It is reasonable to infer that when you're told to download the first 10,000 elements from the pile, you download the pile and take the first 10,000 elements. It's also boring. Yes, obviously this is perfectly correct. From all right. If I just give it the error, does it magically fix things? Well, I'm pretty sure the error is either that it's trying to download TQDM, the progress bar library, as like from tqdm.notebook import TQDM, but rather than being the function is actually the module, or my imports file does that and it's somehow overriding this. Not entirely sure. It's a bit cursed, because sometimes you import TQDM as a module and do tqdm.tqdm. But yeah, whatever. Cursor's fix will probably work. I will totally note that a problem with vibe coding is I am presumably doing more things that I am not narrating, which may or may not make sense. So you are all highly encouraged to just call out or complain if things don't make sense. All right, let's see if I can figure out the issue before Cursor does. So it defined a Kale divergence function, and oh right, it just needs to do like torch nn functional.log softmax. Sure. Wait. Yeah, seems fine. I don't even need to rerun that cell because my imports library does it anyway. But whatever. Irregular encouragement to people to turn videos on. All right. Oh, it made an empty data frame. Woo! All right. What just I think I might have just run the display data frames. It. All right. I give on cursive. Oh, it's because it redid these cells, but I didn't rerun them. That is a reasonable complaint to have, I think. Okay. It says it will take an hour. That is an interesting amount of time. Let's race Claude to see if I can figure out how to speed it up first. I'm assuming it's just doing something where it's doing like each text one at a time, and this is just kind of inefficient. That indeed seems like what it's doing. Do I have a good reason for why this should be inefficient? I guess my intuition is that if you're moving I have like a fuzzy intuition that things are faster when you're doing large matrix multipliers rather than small matrix multipliers. And so having lots of tokens on the GPU at once. Okay. Okay, I'm going to actually apply some amount of intelligence and review these changes. Okay, so sure. But does cursor not give me a okay, option J. Sure. Sure. This is a big rewrite. So it's moved things to the appropriate device. It's giving me the option to set a maximum number of documents. Seems like a fine feature. I don't actually want a maximum. Okay, no. I think that for my purposes, it would be fine to start out with substantially fewer than 10,000 documents, so I'll allow it. And it's doing batches. What is batch size? Whatever. I'll allow this. And nah, I don't care about saving intermediate results. I'm screwing around in a notebook. Sure. Sure, I don't care. Okay, so now we delete this. And we run, oops. I should make these not the same cell, because if it wants to keep editing my imports and being rerun, I do not want that to also include recreating the models. That would be stupid. That is also what I just rewrote. All right, whatever. So now if I do this, maybe it's not a mess. Who knows? I just need to wait for it to reload the model. Okay, so what do I want to do now? So, okay. So hopefully I will soon have a data frame with a bunch of per token KL divergences. What should I do with this data? Broadly, I kind of just want to look at it and be a bit less confused about what's going on. So things I will try. Please create a 2D tensor, no, a 3D tensor, where the first axis is batch, the second axis is position, and the third axis has an entry for KL divergence, log prob of the correct next token for the small model, log prob of the correct next token for the big model, and difference in correct log probs, and then plot me a faceted image plot along the discrete dimension and use the color scale blues. Let's see if Claude can figure this one out. I'm excited. What even is slice? I have never heard of is slice. All right, let's just kill that line. I don't care about this. No, Mecca, no, you care about this line. For now, I keep having issues, so let's just set max docs to like 10, and then I don't actually know what it's trying to do with is slice. So I think what it wants is for dataset to process to be a list, I think. Yeah, it wants it to be a list of text strings. Nope, that is false. Whatever. Okay, so the problem that's going on is that Pile dataset is like a Hugging Face dataset, which is designed to have a bunch of different fields. Like here we have text, and we also have the metadata of where it came from. But like, I just want to think of it as a list of strings. So I'm just going to make a variable for that is just you don't necessarily want to and let's just rename this everywhere. Ugh, where's the rename symbol function? Level. Change all occurrences. Nope, that's apparently also not a thing. Whatever. And let's just delete this bit. And okay, so now we've got a list. Batch is going to be a list of strings. We're going to get the index and the example, and we're going to run it, and life will be glorious. I will note that this command is actually really expensive if pile datasets is big, because it's basically saying load every text data point in this dataset and return it to me as an enormous list, which if this contained like hundreds of gigabytes of text gets kind of brutal. I think Hugging Face datasets has some funky stuff where it stores stuff on the disk. And so it doesn't just kill your RAM. But my dataset's tiny, so I don't care. What? This is ridiculous. Okay, this is a lot more promising. And why did this not appear in my code? I don't. Okay, so it's made the tensor that I wanted. That's like batch by sequence by metrics. I don't like the fact that it's made metrics the third axis. Please make metrics the first axis rather than third. This like should be within its capabilities to just edit easily, I think. It's like a pretty easy edit. Come on, I believe. All right, that just worked. Life is good. Okay, and did this work? What? Ah. Import the make subplots function first, please. Ah, great. Or rather, great if this works. That's somewhat quicker than Googling things. Okay. This is a graph. I like graphs. What do I want to do? So let's call this axis names, and then let's just display and I think that the exact color scale used in a Neel Plotly is a random library of Plotly wrappers I made for myself that is nicer. And yeah, so one generic bit of advice when making these plots is you want to be intentional about where the you want to be intentional about which color scheme you use, and in particular, what the 0 point is. So, like, this one is kind of a pain, but if I instead do this, I would argue this is now much clearer, where I've now set it so that 0 is white and the max is blue, and this is fun. So this is looking a lot like... Okay. I'm curious for observations from people here looking at these graphs.
It's usually the same, but sometimes there are a couple spikes.
Yep. Does that mean anything to you?
That could be consistent with it sometimes retrieving a fact and this not just being like little stylistic.
Yeah. I mean, my guess is that facts are just an example of the kind of difference. They're just one I find it easy to reason about. Like, I expect there to be additional kinds of machinery and circuitry the models have. Like, for example, in some work the DeepMind Interp team did a while ago, Chinchilla 70B could do multiple choice questions, but Chinchilla 7B basically couldn't. But yeah. Okay, so let's just plot the other graphs while we're here. In particular, log prob difference is quite interesting to me. Unlike the others, log prob difference can be unlike the others, log prob difference can be both positive and negative. So rather than using a color scale that begins at 0, like blues, we want to use one like RDBU and set the midpoint to be 0. Oops. Well, nope, that actually worked fine completely by accident because I was equal to the final one because that was what it got to at the end of the for loop. All right, but it's really nice to have a color scale where 0 is white because now it's like very easy to see. You know, most of the time the big model is better, and then occasionally the small model is actually better. Anyone surprised by the small model sometimes being better? And if so, any guesses for what's going on? Yep.
Could the underlying text be wrong in a sense?
That's one hypothesis. Like, though it would have to be a bit more nuanced than that, because if it's wrong in like an obvious way, then both models should predict the incorrect thing. It's like if there's a, it would have to be if there's like a, either if there's a sophisticated reason to think it will be something, which only the 9B model gets, but actually this happens to be wrong, or if, I don't know, there's just like some random noise and it happens to be the case that the 2B knows something the 9B doesn't, because, like, this stuff's kind of random. Stuff like that will happen. One quite nice example of this is one layer versus 2 layer models, because only 2 layer models can form induction heads, and they tend to be really confident about the induction. But sometimes induction is wrong. Like, you have Mr. Smith and Mr. Johnson. Induction says that the second Mr. is also followed by Smith, but actually this is wrong. And the first model, the one layer model, is too stupid to realize the thing that is wrong. Victor?
Yeah, I was going to say maybe some form of overfitting from the smaller one that just is right in some cases.
Yep, I like it. All right, so let's see if we can get something interesting out of this. All right, so one of the nice things about having this data frame is, so all right, so if okay, so first off, I want to just make sure I'm able to get rid of the padding tokens, which is presumably what's happening here. Like, the text was just too short. And actually, this just seems dumb. I have lots of text. I can just take the text out that is... Yeah, I can just take the text out that is less than 500 tokens. This will, like, mildly skew my distribution, but I don't really care. Like, that seems unlikely to affect my results in any interesting way. And this means I don't have to faff around with things like keeping a mask to exclude padding tokens. Please adapt the code that creates the list of texts to analyze so that it excludes all texts that are less than 500 tokens. I could tell it how to do this, but that's a smart LLM. I'm sure I'll figure it out. I believe. Seems plausible. All right. Does this magically work? Okay. Sounds like it magically worked. All right. And let's just check that oops. Okay, let's just actually let's just like add the two kinds of scales I care about. So oops. For anyone unfamiliar, I'm doing the dual editing with Command D, where you like highlight some characters and then press it, and it automatically highlights the next instance of those characters and gives you a cursor on all of them, which is incredibly useful when you want to do random hacking around. All right, so let's make a Kale divergence, and then great. This is not quite what I wanted. And also, please ensure that I get the correct number of documents, i.e., if max docs is 10, you first filter for being 500 tokens or more, and then give the top 10, rather than doing it the other way around, which gave me 4 documents. Since, I don't know, it seems nice to have a larger sample size. Interesting. It feels like it's stopped. Wait. What happened? Oh, interesting. I somehow switched from chat to composer, and this mattered somehow. I don't actually know what the difference is, or understand how to use cursor. If anyone does, explanations greatly appreciated. All right, so what do I want to do now? So, any proposals for what I should do now? Now that I have these interesting graphs. All right, no proposals. Well, in that case, my proposal. Oh, cool.
Oh man, I'm pretty sure this isn't right, but my gut would be to just crack open the tokens, see if we can kind of just get a feel for like what is related to the spikes. Get some qualitative feeling.
That is exactly what I intend to do. Totally correct. On a meta level, I think it's often helpful to think of research projects as being broken up into 3 stages. the exploration stage, where you're just like, what even is this problem? What is going on? Are my foundational assumptions correct? Is there anything interesting here? Where your North Star should just be gaining information. The refinement stage, where you have hypotheses and you're trying to like confirm whether or not those are true, and you're more in like rigorous empirical scientist mode, gathering careful evidence for and against, and then like kind of conclusion and communication where you try to write it all up properly and do all the sanity checking and make sure it's great. And I am currently in the exploration stage. Realistically, we'll probably just be in the exploration stage this entire time because there's only a few hours. And when you're in the exploration stage, I think one of the key questions you should be asking yourself is, what gains me surface area on this problem? Where surface area is my term for just connections and information and weird phenomena and just kind of all of the random scraps of information you get when you actually stare at weird things in a model and to notice things being weird in reality. And I think that often, if you don't have a more coherent plan, just do whatever feels like it would get you surface area is a great plan. And you should not feel bad about not having a plan. And looking at just data and qualitative examples is a very powerful way to get surface area on what the hell's going on. So completely endorse this strategy. Not wrong at all. All right. Yay, looks great. So now what I want to do is, so firstly, I want to add a log prod difference column to the results data frame. And then I want to sort it. And then I want to display the top and bottom 20 things. Nutils.show data frame is just a wrapper around like display df.style.background gradient cool warm, which is a random command that just says display the thing fully and add like color scale to each column where big is red and small is blue, with different scaling per column, but I just find it a bit easier to eyeball. And to Ollie's suggestion of using circuits viz and giving KL the values, also an extremely reasonable suggestion that I will do at some point. But at the moment, I feel like this is going to be a bit easier. All right, so what am I doing? So here is the data frame. Here are things with high KL divergence. And we can also look at the log probs to get a more qualitative sense of like what's going on. Note that I've actually sorted by the log prob difference here rather than the KL divergence. I should probably also try the KL divergence in case anything else interesting comes up. So this is interesting. This is saying that the model is so saying Ristas and DARP synapse program, and the big log prob is like -6, which is like pretty tiny. Like what even is e to the -6? Yeah, it's like 0.2%. But the other one is like e to the -15, which is 3e-7, which is much worse. So the two reasons, well, anyone have any guesses for why something like this might happen?
I mean, the token just looks a bit weird, right? So I guess it's not too surprising that the small model isn't particularly tuned on this. All right, I'm not sure exactly what your question is, but
why might it be the case that you have an like -16 log prob of the small model and -6 for the big model, rather than -6 for both or -16 for both?
yeah, my intuition is like the big model kind of has this extra space it can learn within, and it's dedicated some of that towards picking up this feature, if you will. So like, yeah, it's still unlikely, but 0.2 is obviously far greater than e to the -7.
Yep, that's one hypothesis. Another one is the -16 is just like a really big. -16 is just like a really tiny log prob, and often you get a tiny log prob either when the model just doesn't even consider the token worthy of consideration, which, you know, in this context maybe shouldn't, or the model doesn't consider it worthy of like, or the model is just really confident something else is happening, which drives everything else tiny. And another way to put this is, you can have a big difference when the small model is really wrong and the big model isn't, or when the big model is really right and the small model isn't, but naively both look kind of similar. While, say, here, this is pretty good evidence of the big model being really right in some sense, because -0.3 is like pretty damn high. Though I also don't really quite get what's going on here. So I think that the context before, yeah, so the thing which was confusing me is that if I look, oops, if I look at this line and this line, they're both like adjacent tokens, but this is will code, and this is a living, and there's no will, which doesn't really make sense. My guess for what happened is there's actually a missing token. The like current token is missing, and that what's showing here is the next token. Because then it would be like, the current token is living, the next one is will, and that shows will here, and then here the current token is will, the next token is code, and it shows that here. If this is the case, that suggests the obvious patch is going to context before and just editing it to have a before text. Yeah, so it's got before text. It's got this function called get context. Yep. It is just not including the current token. I am of the opinion that we should just fix this. And also that we should separately have a like current token. We should separately have a current token and next token column. And right, so in my opinion, it makes sense to do things like this, and also it does not appreciate how great transformer lens is, dealing with all kinds of different types in the same function. Ooh, I like predicted token. That's a good one. How best to do that? So so we've got logits. Yep. Wait, what? Why is it indexing with 0? Oh. Okay, so apparently what Claude has decided to do for some ungodly reason is to run with cache, store the entire cache, and then do absolutely nothing with the cache. What? Why would you do this? Okay, now this makes more sense, and we can do mul pred, which is yep. Huh. Great, thanks, Cursor. Okay, so any questions so far while we wait for this to run? Or hot takes on whether I should be deferring more or less to Claude? Oh god, it's filtering every text? Okay, an obvious thing to do is separate out the bit of this that's just like actually running the text, and the bit of this that is like I have not given Cursor the transformer lens dogs. That's a great idea. How do I do this?
I think you can actually link to the web page. Like, I guess you do have them locally, but you can do like an internet reference, and it'll go and search the docs website.
Wait, what? That is incredible.
Yeah, I think if you go at docs.
Mhm. Yep. What was that supposed to do?
Yeah, add. Yeah.
What? This is amazing. Can I also give it the entire arena tutorials? All right, what is it doing? I didn't ask it to do anything. No. No. Maybe, but I don't care. No. All right. Where was I? but hopefully it is now empowered to do more interesting things in the future. All right, so and I'm also just going to sort by KL as well. All right, so this is the log prob bit. Ah. So, okay, so it's a bit annoying because I can't tell what has spaces, new lines, etc. So now I'll tell it to please use the code in usual style, make a function replacing spaces and new lines in the columns of results GF with the corresponding special characters. Where basically white space is just silent and this is annoying, and I would much rather that it instead be pretty. Right? Did this work? Who knows? Ooh, much better. Okay, so now I want to try to just figure out what's going on. Okay, so it's like DARPA's Synapse program. Yeah, so it's like DARPA's. Okay, so this looks like. So I'm assuming DARPA's Synapse program is just like a thing that is kind of niche. And it seems plausible. Alright. I'm now going to ask Claude to make me a function. Please make me a function that takes in a given batch and position index for a token and shows the top 10 log probs of the small model and the big model, ideally as a data frame where the rows correspond to the union of the correct next token, the top 10 tokens of the small model, and the top 10 tokens of the big model. And there is a column for log prob of small model, a column for log prob of big model, and a column for is correct. And construct it so that the correct answer is always at the top. And then it sorts by the big model's log prob. Let's see if Claude can handle a request with that many constraints. I believe. You can do it, Claude. I can do it. Did this do anything? Wait, what? Ooh. What? This looked like what I asked for. And is also kind of cool. So it looks like honestly, I don't actually know. What happens here? So it's still not completely obvious to me whether this was the small model being really confident in something incorrectly or something weirder. Please also print the total probability each model gives to its top 10 predictions. Not add to the data frame, just print as you are computing this. And yeah, let's stick this in. Whatever. Yes, I'm sure everything you did was correct. Okay, this doesn't actually look like it's the small model screwing itself over. And I guess the fact that the rank is like 3,000 rather than 61 is instructive. But, this is like kind of interesting. Okay, so what else do we want to do? So this is just generally kind of annoying because, wait, what? These all spaces? What does it do it? Okay, so another thing worth doing is please use nutils create HTML to visualize the tokens of a text colored by their KL divergence. Please take in an optional parameter to this function that is a specific token index and edit the function to bold this token index. This is going to try to display a heat map of the text colored by this is 381. Right. It's also occurred to me that I'm not even using thinking Claude. So if I actually care about seeing whether it one-shots something, maybe that would be a more fun way of doing it. But, well. Nice. What's Claude max mode?
I think it's like a cursor wrapper around Claude where they give it like a shitload of context and then they let it. Oh, do you not have it? Yeah, I think it might be in the. I think you've got a cursor up there waiting.
I have Gemini
Oh, no,
2 Pro Max.
Yeah, that's the one that I'm. It's the same kind of thing. I think they might have also a Claude Max in the. Oh, sorry, Jasmine. The Claude Max official Anthropic product is the subscription that they also called Max. But I'm pretty sure Cursor also built a thing that they called Claude Max, which is like the same thing as the experimental Max thing here, which is like where they index way more of your code base and put way more of it in context or something like this.
All right, I guess I'm trying Gemini 2.5 Pro Max. Can see which model is better. That'd be great. I just roll with defaults. Okay, so all right. What? Back to Claude it is. Okay, what if I just use the non-experimental option? Hmm. Wait, did it make the edit? Great. Come on. All right. So this is weird. And it's broken in the middle. Why is it broken? What is going wrong? Why does it look like this? Whatever. It's here. Okay, so it's saying okay. So there's high KL divergence. I presume KL divergence is about predicting the next token. So like it's not that they don't understand there's a angle bracket there, it's they disagree about what happens next. I think there's an additional one confounder of the KL divergence based metric is it could just be highlighting high entropy tokens, I think. Because, you know, if something's really uncertain, then like a small bit of random noise might completely change the answer given, but not in a way that I think is very interesting. If that makes sense to people?
So you could do like the KL divergence of the top in probs or something like that.
I don't think that would solve the problem. So I think what I'm arguing is more like, Suppose that you just have no idea what's going to happen next. Like, it's just the first word of a document, and you're like, And that's a bad example. Suppose you've just got a really chaotic text that just randomly selects sentences from like 100 different documents, and each sentence is from another document. The correct thing to do is to output a fairly uniform distribution over next tokens. Or like output a kind of pretty flat distribution. It's kind of random, and it's going to end up favoring some things but not other things. But like, it's pretty unclear what to do. It seems like the Kale divergence should be much higher here, just because it's like more chaotic. I'm not confident that what I just said is mathematically precise, but feels like there's something here. All right. I am flagging a bit, so I'm going to go take a 10-minute break. Meet people back here at 50 past. Hello again. All right. So I now want to take a bit of time to recenter and think about what am I doing here? What are my goals? What would an interesting resolution to this look like? So yeah, I'm gonna take some notes as I think aloud, because that's often helpful. Notes doc. Okay, so like, what do I care about here? One way to orient to this is just make a list of questions I want to answer. Is the increase in performance driven by large changes or small changes, or a mix? What does the distribution of tail divergence and log prop diff look like? Can I find evidence of circuits learned by the big model, not present in the small model? Okay, so this highlights a nuance for me, in that I would be happy to find an example of a circuit learned by the big model. Let's say capability. I'm not realistically going to do any circuit analysis today. I would be happy to find a capability learned by the big model, but not the small model, even if most of the performance is driven by tiny changes. I would also be interested in learning more global statements about what drives performance differences. Like, what drives, like, key differences. Does that nuance make sense to people? Oh. Okay. So okay, so this motivates the obvious idea of just plotting some histograms and trying to get a sense of these two. This one seems easiest. Okay then. Let's add in a marginal plot so it's a bit easier to read the tails. Yeah. As a general meta point, just being very fluent in plotting libraries or being good at getting Claude to quickly write them for you is a pretty crucial skill. Okay, so what I'm getting when I look here is I know this is kind of hard to interpret. It's just like, well, you know, it's mostly near zero, and it's sometimes big. Here, again, mostly near zero, sometimes big. You would kind of expect, I don't know, even just a copy of Gemma 2 2B trained with a different random seed that has nearly identical loss would have a tail divergence distribution vaguely like this. Like, there should be a bunch of noise. It's not super clear what to take from these. But, you know, I'll copy them down into my research log. It's nice to be able to look back on things like this. Okay, so what else? I would like to well, so first off, I'd like to just understand what the mean is. Like, what is the log prop difference? And I'd also like to understand oops. Thank you, Claude. F strings are unhappy when you have the same kind of quotation mark inside of them. And I think I would also like to plot okay, so it's a marginal change in loss. And okay, so I have a new idea for a visualization. So I'm kind of trying to capture this idea that I'm kind of trying to capture this idea that how much of the total log prob difference is driven by small things versus big things. I tried pulling this graph, which was just like the cumulative sum with the like rank on the x-axis, but I found this kind of hard to interpret because I'm like, a lot happens between in the last 10%. Is that a big deal? Is that fuck all? I don't know. Like, I kind of care more about things like if the standard deviation is 0.2, then how much of what's going on is explained by things that are above 1 or something like that. It's also a bit confusing because you've got like negative bits and positive bits. It seems like the total negative bits are like less than half of the total positive bits, so this is like not the end of the world, but it's a bit messy. So what I'm going to try to do is do a scatter plot of go and do this. Yeah. But the x-axis is the log prob difference, and the y-axis is the cumulative sum. Is this going to look insane? Oh, that's kind of reasonable. Okay, and I'm also going to do. I'm also just going to print the standard deviation of I'm going to print the standard deviation divided by the sum. What? Why is this sad? Who cares? Oh, okay. It's sad because I'm kind of taking a column from a data frame and then kind of messing around with it, and it's like, is this bad? Maybe this is bad. So I'll just make a copy and then I don't have to care about it. Okay, so oops, wrong around. How much are people currently following what's going on?
I'm kind of confused about what you're trying to graph here, I think.
So, I mean, mood. Roughly what I'm trying to do is graph. What am I trying to do? So, the high level question I'm attempting to answer is why. How much of the total difference in loss is driven by big values versus small values? Fundamentally, this is just taking a sequence of positive and negative numbers and just trying to say how much of the sum comes from big bits versus small bits. This, is not like a particularly novel or complex problem, but I'm not aware of a standard solution to it. But I'm saying, well, a thing you could ask is if you exclude all data points with with absolute value less than n, then how much of the total sum have you produced? And that is what I am attempting to plot. Ooh! I think this is what I was looking for. So this is basically saying, well, if you look at that's actually pretty good. So this is saying like, well, if your log prob diff is less than 1, then you only explain like 33% of the total, which is kind of interesting. I guess there's some confounders here, because one of the annoying things when you've got positive and negative numbers is if you just add them up, you can get weird cancellations, while if you add up the absolute values, then you get your denominator is just unreasonably large. But Let's just try doing that and see what happens. Because this should just be like a... Yeah. This is just a... Yeah. If I do abs... Oops. Why does this hate me? Nope. All right. My thing is just being slow. Okay. So this seems to actually be saying that a decent amount is driven by big things. So this is now the sum of the absolutes sorted by the absolute value. But I'm plotting the like actual value on the x-axis for some reason because I'm lazy. And this is saying like, I don't know, 60% is explained by log prob diffs above 0.86. Just like reasonably big, in my opinion. Obviously, my sample size is not very large, so if I was actually doing a proper investigation, I'd scale up, but I'm lazy, so who cares? And... Okay, so what do I do with this result? So another question is how much of the performance difference is driven by times when the big model is just right versus being driven by I don't know, both models being wrong, but the small model being more wrong or something. A way that I could test this is by plotting the same kind of graph, but rather than sorting by the log prob diff, I sort by the big model's log prob. Because then I'm saying, well, how much of this is explained if you look at the things below or the things above? Ollie?
Hey, yeah, I was thinking, what if you do like a 2D heat map where each of the axes is the each model's error, and then get the like or maybe not heat map, scatter plot, or just like the areas of density of how much is in like one model's right, the other's wrong, vice versa.
Ooh. That is interesting. I don't know how I'd make that, but good thing I'm doing vibe coding. Please make me a 2D histogram, which on the x-axis has the log prob of the big model, on the y-axis has the log prob of the small model, and the color is the total log prob difference between the big and small model. That is total, not average. Oh yeah, I'm currently using a dictation software called Super Whisper that also pipes what I say through an LLM, which is why it is not faithful to exactly what I say. but it also looks prettier. Though sometimes the LLM decides that my diction should be more formal than it actually is. It's kind of a pain. All right. Okay. Let's say how does this even work? Ah, this is a function called density heap. Interesting. And so I can also do the absolute. What? Oh, I can also do the divide by the absolute sum. No, I prefer the previous one. Okay, so what should I take away from this? So, well, first off, what is this like? Okay, it's the y equals x. Great. And yeah, so the annoying problem is that I kind of see this and I want to interpret it as 9% comes from this block, but that doesn't quite work because there's positive bits and there's negative bits, which are like partially canceling out. But it's kind of like the positive bits add up to 1.8, and the negative bits add up to like minus 0.8. Honestly, I don't really know what the principled way of dealing with this is. If anyone happens to know what people who encounter this in research do, hit me up. But yeah, this graph is also kind of hard to interpret because times when there's a big difference are going to be a lot more spread out than times where there's a small difference. So the intensity is going to look pretty off. If that made sense. Like if you imagine the bucket of log prob difference less than 0.5 and log prob difference bigger than 0.5, the first one has like a small number of cells. The second one has a lot of cells. And like all of these, and I'm like, well, what's the sum of these? But I don't know. Anyone looking at this have any notable takeaways? Or confusions? Yes, I think my takeaways are just something like, well, there's clearly a larger concentration closer to the origin and closer to the line, meaning small differences. And it does seem like there's more things where the big model is a lot more right than the small model. Many of them, both models kind of suck, but there's also like a fair amount of stuff here. Basically nothing here. Meaning, so these are times when the big model knows exactly what's up and the small model is confused. These are the reverse. And yeah, okay, so what can I take away from all this? You can also just want to have smaller bins. Bins. Great, looks much better. Bit more. Why? Ugh. I do not understand how this thing works. But hey, I don't think I'm going to get much more insight from staring at this heat map. It kind of feels like, well, it's a bit messy. Both kinds of things are going on. Big changes do, in fact, have a fairly significant effect, but it's, you know, not overwhelming, and it depends exactly how you define big. And as with all things, kind of median occupies quite a large chunk of the space, and the tail events do not. So in the last like half an hour-ish, I want to pivot from this like general phenomena studying to trying to find specific examples that are interesting, that indicate the like some concrete thing being learned by the big model that is not learned in the small. Anyone want to suggest how I could go about doing this? So, to me, the first place to start is thinking in terms of metrics. Like, I've got 5,000 tokens, I could easily generate more. What are the properties of this that make it interesting to study? In my opinion, the key properties that make something interesting is when the big model knows exactly what's going on and the small model is deeply confused. And because generating data is cheap and my goal is to find something interesting, it's fine to set a fairly harsh metric that would exclude a bunch of things that are also interesting. So I'm thinking something like the correct answer is rank 1 in the larger model, and its rank is like worse than 50 in the smaller model. Seems like a reasonable proxy. Please filter the data frame for tokens where the next token is the most likely predicted token by the big model, but is rank worse than 50 for the small model. This is probably actually very easy to command if it has the thing stored, but I remember if it does. On. Can you instead go through the original code for generating the data frame and adapt it to also add the additional columns for ranks? Great. That looks like code that works, probably, maybe. It is fast. Pretty weird how fast the best LLMs are nowadays. Okay, and I'm also going to increase the number of documents to like 100, so it's more likely that I find something interesting. Hey. How did that take that long? It wasn't even running the models. This cell is really slow. Please fix. What? All right, that is slightly more efficient. Though, no, it does not speed up tokenization to go in batches. If you then batch each text if you tokenize each text in the batch separately. This is not how this works. But whatever. And oh, these are some extremely bad small ranks. Okay. For the first 10 rows in the filtered data frame, please display the text up to that position, including the next token, and color each token by the log prob by which the big model scratch that. Color each token by the difference in log prob the big and small model assigned to it. Importantly, this is offset by 1 to how results DF currently works. I want each token to be colored by the probability that it is predicted, not the probability that the next token after it is predicted correctly. There's this kind of annoying thing when you're trying to do these text-based heat maps where this whole, like on every token in the text, the model is predicting the next token, but also kind of processing the current token. And so these, in some sense, for everything the model does on a given token, there's actually 2 relevant tokens. And so when associating each token to some metric, you can kind of choose to do it like the natural way or shifted by 1, and both make sense in different contexts. So, you need to just pay attention to what you're doing, and in particular, what other people are doing when you're reading a paper. And I think in this case, I care more about, was this token predicted, than did we figure out the next thing well? All right. Why is this sad? Oh. It's also useful every so often if you're using VS Code interactive modes to clear the window, because it can accumulate large amounts of big things like Plotly plots, and this can eat up a bunch of memory and leads to weird, annoying crashes. Okay, so fascinating. Please edit that code to also print the top 10 next tokens given by both the big model and the small model, and their associated log probs and probabilities. 10 was too high. Let's do 5. Okay, so looking at this one, this seems like some kind of medical form, and I know, I could believe this is genuine factual data. Like, okay, so Mark Huckvale. Okay, so the actual thing that was predicted differently is like this Gebra WAD. This seems like a factual recall thing. Like, so Gordon Capes. Is that a celebrity? Well, not a celebrity, but like a kind of known figure. Yeah, president at Studio Technologies Inc. Sure seems like a case of just the 9B knew something the 2B didn't. So let's try another way of doing this. Golden Capes is okay. Uh, well, so neither is very good at this. Though note also that I'm studying base models rather than chat models, so they haven't even been trained to refuse things. But okay, so if I take but this isn't an amazing test because it's plausible the model knows that like audio stuff implies this guy while other things do not. How about this? At the audio forensic held by AES, Gordon, nope. 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 Why does it want to say M dot? Okay, whatever. I am still going to call this factual knowledge. And just to be like, this seems kind of on the limits of the model's ability to reason clearly. So no big deal. But yeah, so yeah, Gebra Wood. I assume it's just like another known person. Alright, the small model is like Gebrek, apparently. Yeah. The small model just does not. What? Why does the big model? Is Gebrek like a word? Huh. Gebrek is Dutch for lack, apparently. Alright then. Learn the most random things interpreting language models. Okay, so there's just some more examples. Gordon Cap. Yep. So this is just like, let's just guess some things. And this model is like pretty confident. Oh, wait. I just noticed that it has this enormous hint about who the person is. So let's try big dot generate. Yep. All right. Well, it was going so well. Let's make it greedy. So it's deterministic. Great. And small model will fail. Yep. All right. I am pretty comfortable calling this the big model just knew a fact and the small model did not know the fact to an acceptable degree. Does that seem like a reasonable interpretation to people? All right. So I'm now bored of this example. Slap, straff, men, Mr. Lapen. What? Anyone have any idea what this text means?
My guess is name. Maybe a fancy name with like a title-ish thing.
All right, that's a guess. Well, I mean, I guess an obvious thing we can do is just look at the thing. What?
It's just not English, I guess.
It's Norwegian? Get a penalty but lose the ticket. Huh. Okay, let's try this. Well, this is Danish. In the language of. Amazing. It's getting some vibes. No. Okay. Okay, so if I tell the small model this is in Norwegian, it's a lot better, I'd say. Is this valid Norwegian? Wait, what am I doing? I can just ask Gemini. I'm sure this is a great use of Gemini's context window. Mm-hmm. All right, just sounds like the other model is done. All right. Yeah, I like Ollie's suggestion of seeing if they can translate. It's honestly surprisingly on topic, given that apparently Lapid is driver's license. I'll allow it. Oh yeah, let's use greedy sampling. No. Avoided punishment, but loses. That's actually pretty good. All right, the big model can speak acceptably terrible Norwegian. No, not at all. What if I'm more explicit? Translated to English, that's not terrible actually. Let's make it do more tokens. Uniform this up on the wrist with these badge. Okay, it's got caught in a loop. Fucking base models. Okay, I'm pretty happy calling this. The base model was better at recognizing that it was in Norwegian. Ooh, here's an idea. Complete the following Norwegian sentence. Here is the translation. No, wait. Loop. Okay. Oh, that is ridiculous. Blatant cheating. Yep. I am happy with that. Now, can the small model do it? The real questions. The punishment. What? So it's saying, let the punishment be severe, but lose the paper. This is a common saying in Norway that means the punishment should be severe, but the person should not be punished too harshly. What? All right. I am happy calling this. The big model is just better at Norwegian. Honestly, I should have moved on earlier, but that was fun. That's pretty cool, actually. That feels like a real result that I did not predict ahead of time. I also initially was like, oh, it's because it memorized like headline, but that was actually like way more complicated than necessary, and it was just, well, in my opinion, it was just, it's Norwegian, speaking Norwegian. Let's just finish it with a sensible Norwegian word. Okay, what's this one? Linux kit elves. Huh. Anyone happen to have any idea what this is about?
I mean, I kind of stand Docker. Could you print out that text with the new lines not rendered out? Like it almost looks like a terminal output.
with like, especially with the version number at the bottom and the dash name at the top, dash restart always. Yeah, that definitely has a terminal command at the top. Oh no, okay.
Oh, is like a post on like a forum
Yeah,
for advice? Honestly,
Yeah,
to me, it looked like someone asking an LLM.
yeah. I think that middle chunk is like the output of Docker something.
Docker system info.
Oh, right there. Yeah.
Okay. Let's try to figure out what this thing is. And no. I Google that, some random things come up. It seems to be like a real string that happens. And it seems like the big model knows it and the small model doesn't. I guess. And yeah, like a lot of these, where the big model also does well, they're like the start of lines, which makes me speculate that this is like a standard Docker command with like a standard output syntax that the big model has memorized and the small model hasn't. It's actually pretty testable. Oh no. Yep. That didn't work. After I ran Docker system info, I got the output. Yes. On, I believe. All right, let's try again. Thanks for the debugging help. And it worked, but I don't know how to interpret what it means. All right, that had better work. If it doesn't work, I'll just give up. Come on. Nope. All right, whatever. All right, let's just quickly skim over the other examples. Some more Linux stuff. Is Knuckle nonce 5? Non-shared? Yeah, that seems like a pretty reasonable conclusion to me. Oh, wow. 99.9%. And it is, in fact, correct. Wait, what? So, there's something about Chromium code reviews, and also AI Overviews seems to think that it is a non-software fault isolation compound? What? Okay, AI Overviews seem confused. But these seem to suggest it's some like specific term in the context of Chromium. So I'm going to again put this down to 9B just has more niche programming knowledge that 2B doesn't. This just seems like another. There's some court case. Yeah. I don't know. Let's just Google Scientology court case 1976 Morgan. Let's see who comes up. Well, nothing interesting came up. I don't know, man. But this feels like a thing. Ooh, a rare example of 2B winning. Yeah, more Docker. Yep, more memorization. Sorry?
This kind of makes it seem like the bigger size doesn't actually give it that much. Like, it seems like very non-generalizable knowledge.
I think that's a bit premature to conclude from the data so far. Like, I'm deliberately taking a very cherry-picky strategy of filtering for, like, base model confident, small model has no fucking clue. And, for example, if the big model had the correct reasoning circuitry to do a multiple choice question, and the small model didn't, this could manifest as the small model being uniform and the big model being 100% on the right answer. But the right answer would still have rank between 1 and 4 for the small model, so it wouldn't flag as interesting to, like, my thing. So, like, really all this is telling me is, well, it's not that rare for the big model to know important facts that uniquely determine the next token, and the small model to not. The fact it's implied are, like, somewhat activatable by the context. I do think the Norwegian thing is, like, actually pretty generalizable. Like, inferring what language you're in is a pretty generally useful circuit, I'd say. Though it's the kind of thing that's probably most useful early on when it's not obvious what language you're in. Or, like, immediately after a shift, after, like, 100 tokens, it's probably pretty trivial to figure it out. Yeah, I don't have a strong conclusion from this about, like, the relative prevalence of different things. Though I agree it's some evidence. But yeah. Alright. I am concluding the official research stuff here. Happy to take any concluding questions or thoughts. And I'll commit the code and share. See, Ollie has something in the chat. Yeah, we could do a get interesting example strategy that works across tokens. I think your idea of, like, several high log prop differences makes sense. One concern I have is that I don't even know if I expect there to be that many high log prob tokens in a row, because often, I don't know, you'll have, like, a multi-token word, and figuring out the first token's the hard bit, but figuring out the second token conditioned on the first token and everything else is kind of trivial. Or, yeah, basically the way I think about it, a lot of the tokens that are hardest for a language model are the most open-ended. Like, getting a token within a sentence is typically quite easy because it's quite bounded, typically you remain on topic, you have lots of info, etc. But like after a full stop, it's a lot more open-ended. After a like paragraph break, it's even more open-ended, etc. And I feel like those open-ended ones are the ones you're most likely to get big benefits from increases in size. This isn't universally true. Like I'd expect the Norwegian one to have like lots of things in a row, but say in the Docker one, it was confused about what happened at the start of each row, but at the start of each line. But like once it had that, I don't think it was that bad. But could be cool to explore. All right. Any closing questions? Yeah. Cool. That's all. That was fun.
Thank you.